Alright, I think it's recording, and yes, it is. Okay, back again. And now we are talking about still dual corpuscular time shared spaces. Particle reunitizing reality makers, which happen to be black holes. Sometimes they talk about free will in science. What's funny is that whether ultimately there's some point at which humanity is going to make the same choice, whatever you want to say about choice, it's not going to change who you are, right? Well, let's see. Now, without going into that, at this point, it makes you wonder, are all particles singularities? Tiny singularities. Of course, this has been mulled over before. Could be. It's basically supposed to be proven not, but it might be that we just don't know the nature of those singularities. There could be different kinds of singularities. So I raised the question, wouldn't each singularity just unitize to become one singularity? Or do singularities keep their individuality? Well, they must keep their individuality. We've got lots of them. But if a singularity is in a singularity, if you consider our space, which has space-time and superposition time, which is the dualistic corpuscular time-shared space, which means that we came from the Big Bang and the black hole that we never left, which means that in our dualistic corpuscular time there is singularities, so that means that singularities can be inside of singularities. This would mean singularities become closed to entering. There'd be a possibility that anything trying to get in could just get slung around, like a singularity that just doesn't let stuff in. One way you could imagine that possibly is, what if there was a singularity that really didn't have any space in it? Like at the moment of the Big Bang, there's some talk about how they believe that there was tiny singularities formed, although they have time limits on how long those could last. But I don't see those as being accurate, because we talked about how if you take a space particle, you divide it into two, and if within those two space particles you have no frame of reference, you're not going to be able to tell the difference. Not only that, let's say you have one that's 50,000 times bigger than a tiny one, you're still not going to be able to tell the difference because you have no frame of reference. Without a frame of reference, how are you going to decide how long one can last if you don't know the mechanics of it in the first place? So, no, I don't agree with tiny singularities. A year ago, I don't even think I had an opinion 2 years ago on this. I just read what was out there. But now thinking about it, as I delved back in because of my desire to make this model and making the model, let's say the probability of the wave function is an orbitable affected by close proximity particles that are within the frame on the core. All matter seems to be in sync, or the image would just be fuzzy in the case of light. Yes, it is still there still is an interference, but if a solid is acting like light, then we must consider these interactions and why something like gold is acting like light. Oh, I covered this a little bit before. I started a little bit back to overlap a little. I see what I did. Okay. I covered the same page partially, but it had an interesting start. Singularities in a singularity. So why are there many degrees? Why are there finite? Well, I don't know if I'd say that, but why are there many degrees of freedom in a black hole? Or independently, each particle has its own set of freedoms, and that's because of a form of relativity. From a relativistic point of view, that particle's in the middle, and every other particle is and from one point of view, they're not even there. From another point of view, they're inside of the Planck length, and from another point of view, they're in the Planck length plus the particle. And so all points of view are basically valid, which is a kind of a fourth dimensional thing. A real point of view, though, not just a thought experiment point of view, is the particles in the singularity alone, the particles traveling in the singularity in the trajectory it takes when it fell in, and or the trajectory it ends up with, and it's a permanent trajectory. Then also from another point of view, from the space particle point of view, that has the that particle captured, and of course it's reunitized. Remember, the space particle has that particle captured, dead still, from its point of view. But space is actually following that orbit that particle is taking to hold it still. Weird view, but that again is the extended form of relativity. What is it when you get down to the Planck scale, to the 10 to the minus 33 centimeters or 10 to the minus 43 seconds? So the 10 to the minus 43 seconds is the update time of the core. That's when time passes here at 1/10 to the minus 43 seconds. And interestingly enough, I was just thinking about if you accelerate something in space at the speed of light, the update of the aging process of that item stops. The acceleration doesn't stop, but the aging process stops. If you slow it down, the aging process starts back up, and the acceleration process slows way down. Something seems to break in our picture of a smooth continuous space-time. That just sounds like a video that I must have seen. For the most part, time is pretty good. It doesn't really have any distortion effects, except for at the higher speeds. There's slight distortion, but nothing that heavy. Even GPS doesn't take much to set it straight. We can see this from, let's say, space-time. It says break in our picture. Okay, something seems to break in our picture of a smooth continuous space-time. We can see this from thought experiments. If you try to build a clock that could measure time more finely than 10 to the minus 43 seconds at a time, then your clock would take so much energy it would collapse to a black hole instead. Well, to me, the time limit is more interesting to know as the time limit, and accepting it, because that tells us the time that our space-time ticks at, and in superposition, that's the time that it takes. That's the time it uses to build each incremental step of our time. Space-time, space and time, are they discrete at the Planck scale? And the answer seems to be yes. It might be yes and no, frustratingly, but for this mental example, it's yes. So the Planck scale of 10 to the minus 33 centimeters about is smallest update of particle component in our reality, and 10 to the minus 43 seconds is the update clock of our reality. This proves my point about the interference pattern at pseudo-light speed. Planck mass about 22 micrograms, the smallest particle with the mass with mass, and Planck time around 10 to the 43 minus 43 seconds, Planck length about 10 to the minus 35 meters. So the mass is news to me, but it was. Likely it is the smallest particle, or divisible particle with mass. Okay, what is that again? Let's take a look at that. That was Planck mass, about 22 micrograms. So I wonder, well, I guess it would vary. I wonder how many Planck lengths is 22 micrograms of a mass. I should say the smallest mass component. This is likely the equilibrium particle. I wonder if that could be calculated. Anybody know? Planck time, the smallest flow of time. Planck length, the smallest updated point in space, with jitter or error correction, or quantum jump. Basically, if it's a fingerprinted pattern that creates us through the Planck size, if it's points of singularities going through these Planck sizes, it does keep it, so it's a limited update, but it also creates a unique fingerprint for each one of us. This allows for the large space particle to be divided into limited updated background. If it wasn't, it would never finish. I realize that if it is infinite, it would be finished in one cycle regardless, which boggles our mind. But from the point of view of my model, it's limited. It seems each frame in the black hole can entangle, and two frames can become one frame. Under my theory, the reality we are in would look the same matter where we are in it. This is the expansion of space and optical illusion. A world can be tangled within frames, or think of it like stacks of particles next to each other. Entanglement is everywhere, and cancelled gravity is everywhere throughout space-time, except at the quantum level. Sure, the Planck scale, but entanglement may extend it, or particles that fit together may extend this effect. Nonetheless, the cancellations are true and look like this stacked throughout our space-time. So, like that right there. I noticed if I got too close, it starts blurring. So, at every Planck point, you have another one of those, and so all of them together just cancel out the gravity that would normally rip us apart. It makes the black hole gravity cancel out, and the untouched gravities, those of mass and particles, this gravity is allowed to leak through, called the weak force. All of the gravity in space is cancelled. Every point in space is the center. Not just seems like the center, but it is the center. This is how our beautiful universe is. It has composite. Something down there, make noise. Alright. It has composite crepuscular times that create a gravity-neutral space environment through the use of the space and particles that fall into and form a point of singularity. You hear that? That's the bass. The center of the black hole, the center of this black hole has all the space it had captured. This space is then filled with the most simple base particle that throughout near infinite gravitational pressure has only been resisted by near infinite centrifugal force from this base particle that is reunitized along with all energy and mass possibility particles. General relativity is preserved in each corpuscular time. Two basic corpuscular times exist in a black hole. One is super time and the other is reality time or superposition. I don't know why I said reality time. Let's see. Oh, super time. I said super time. So it was actually superposition. The other is space time. There are a lot of dualities in a black hole. 1, super time. 2, our time. And 3, black back in time. But limited, like a short-term buffer. How long? Don't really know. But likely long as it needs to be. But to be clear, these are quantum times, so it is likely to be related to the Planck time. Not really one moment of Planck time, but like the time it takes a particle to move from one point to another. There would be some rules that are limited, as in the bomb tester experiment. Time is not an illusion. You do have neurons, and a particle is there, if you see it or not. There are particles that could be in an orbit, and the wave function is a wake of the orbit that creates a local limit in order to stop a halting problem in an infinitely divisible space. You think, let's see. Sabina Hosenfielder's video, you probably don't know why you really have mass. A great video showing me somehow we will have to work together to complete my theory. So my theory is a basic concept of corpuscular time that is closing a gap between general relativity and the quantum realm. Black holes create quantum relativity within its own reunitized corpuscular time. It's like matter with its arms held in. General relativity and quantum relativity are like a transmission, linking two different time spaces together inside a singularity. A black hole is a composite corpuscular time setter. There is a massive amount of connecting science to this theory, but there is so much knowledge out there that I think that everybody could help to see where it interfaces. If you like it, if you don't, that's your choice. Please don't, let's see, I said, please don't drift into idea science, but remember, just because you don't see it doesn't mean it's not there. We do this for useful things, not to chart down a bunch of stuff to come to an unrational decision and suddenly say, we don't exist, the matrix is real, I don't have neurons, there are endless copies of me out there. These things are nonsense and non-science. For people that mostly don't believe, in stuff, they sure have a lot of belief in different kinds of things that are not about anything. But anyway, even if you want to believe in some of that, it's your choice. I just realized that a particle or a singularity could keep everything out of it through infinite spin, or let's say if there's a black hole type where it's just stuffed with matter and there's no space inside. The space would be inside the space would be inside of particles, but not extra space within that singularity, which would mean that there might possibly be able to be a black hole that could, we say that nothing can get out of a black hole, but what if nothing does get out of a black hole? Like the nothing of a singularity. What if the singularity can divide itself and come out of the black hole? Doesn't seem like there'd be any real rules against that. In other words, you take a singularity, and if it was to divide into two singularities, then there wouldn't have been anything that came out, would there? Huh? Or, easier yet, a huge singularity spewing out little tiny singularities, kind of like what it looks like when you have a black hole and two ends of it pluming out matter at like 2/3 the speed of light. Maybe it's quantum tunneling out of that thing. That's what it looks like. Excuse me. Let's see. Your infinite spin that forces all particles around the singularity if attempted entrance is perfectly at, say, a pole of the singularity, it should then be able to enter. If a particle is at its smallest possibility, then it is at Planck's smallest mass size. Theoretically, the center of a particle like this has no ability to be ripped apart any further. It would possibly be crushed into non-existence if not for near infinite spin and near infinite centrifugal force, creating an equilibrium. When I say near infinite, I don't really mean that. It's just an easy way of just kind of like dramatizing it, you know. This is a base unknown particle unitized. Multiple singularities with doors that can be locked, meaning a particle singularity that falls into a black hole cannot be destroyed, but the pressure from the black hole reunitizes it in the space particle in the center of the black hole at every Planck distance, with the Planck distance being an infinitely small particle could pass through it at any point. Within that limit, this probability or jitter effect stops the halting problem of infinitely divisible space. That's looking through as though the update particle going through this Planck length, whether it's circular or square, would be infinitely small, but it would still stop on infinitely, a halting problem, because if you updated every amount of space with an infinitesimally small thing, it never ends. It would just go on and on and on, especially if it was done one spot after another. The infinitely small can pass through at any point within that limit. This probability or jitter effect stops the halting problem of infinitely divisible space. All particles must have a closed door singularity, a shield effect, just like Earth's magnetic field. These design our universe and explains a lot. Could there be antimatter singularities with closed doors, meaning no access possible? It's a thought. That would be a good place to put the antimatter. Inaccessible. I hate to think so, but who knows? The space particle flows infinitely through, canceling gravity at anything above the Planck scale. And let me see my time. Oh, I got a little bit left. Let's see, actually it can be viewed as simultaneously space flows and causes an instant update as viewed from here. Since we are finite, I find the first explanation easier to conceptualize. Space particle flows infinitely through, canceling gravity at anything above the Planck scale, and actually it can be viewed as simultaneously space flows and causes an instant update as viewed from here. I find the first explanation easier, which is, anyway, I don't know that it's relevant, because like if it's one trajectory of like with light, it's electromagnetic, and so if there's electromagnetic that forms matter, then you would have the update process that's persistent would be updated. In this case, it'd be like gravitons, and gravitons would have probably a similar process, because they'd be a particle, and then that would be pulling down on everything in all directions. And if it's only allowed to be at the Planck length, that would cause every Planck length to be part in a limited space. If they were all the way through and you put your hand in there, you wouldn't feel anything because it would all be cancelled. A different kind of black hole might be a particle spitting out fixed singularities, potential particles from the poles. Maybe different black holes have different functions. I know nothing can get out of a black hole usually, but there is quantum tunneling that not supposed to be able to go through walls either. And I previously gave a possible theoretical example of a strange black hole that stacks all matter in a rotating pillar in the black hole like this. And then at the poles, this thing wouldn't look exact. In our space, it would just look like a black hole with matter shooting. I know that we think that this is matter streaming in and coming up to the poles and then being accelerated off the end. But technically, those ends are rotating, not spewing matter out. So, a bit of a mystery. Let's see. Would this cause a rupture and overflow problem? In other words, inside the black hole where matter wraps in around itself, if you had a solid pillar within the space-time, and it went all the way through, would this cause matter to be able to get out of both ends? And why and how and all that good stuff. An overflow problem at both ends. If you turn this really like this, the singularity, if you take this thing and you turn it on its, turn it 90 degrees, you could look at it like this. And like this, the singularity is still there. Just a different view of it from this point of view. Are we seeing this in space already? Because I've seen some videos of that. And the gravitational lending proof of a closed-door black hole. It would mean like you'd have like a swarm of bees, that don't interact, and light could go through and just like it would act very much like a lens. And there would be no light there. It would still be dark. So, is that out there? I think I've seen some of it on some of the new photos. Almost looking like smears and smudges of light. It's not repelling light, but redirecting it. Quantum relativity, every particle is in the center of the black hole and space wraps around the particle instead of the particle traveling through space. Both is completely true. Let's see. Time. Not much time. A few seconds left. So this is quantum relativity, but also it is simultaneity space. All matter is in the center of the singularity at the same time. Taking thrust from a rotating body is kind of a slingshot effect. If a body is moving in such a way or has enough mass, it will pull out of this corpuscular time into a new unitized time, being out of phase with the origin time. A singularity that moves its poles constantly away from anything trying to enter it has an equator that would induce a slingshot effect from any angle all the time, because the particle singularity can move in such a way in relationship to the corpuscular time to avoid all attempts to enter. It doesn't repel exactly, but it rotates the other body around itself. The simultaneity part is in exact contradiction to special relativity, an opposite form of special relativity in the black hole. Oh yeah, because of simultaneity. Yeah, that's interesting actually. Let me see what I got for time here. That's it. Have a good one. Few seconds.